All right. So just messing around with average ifs, some of this, the plurals, you can see that having multiple Boolean conditions allows you to make a lot more powerful decisions and pick the kinds of stuff you want. There's a couple of other functions that have the same idea in mind, and they're the and or operators. And again, they just return a true or false, depending on the conditions. Like with an and, you have two things, like I'm male and I'm over 21. If both parts of that are true, it's a true statement. If either part of that is false, then it's not a true statement. Well, but if you say I'm female, if I say I'm female or I'm over 21, that's still a true statement because part of that's true. For ors, both parts have to be false for it to be false. For true, both parts have to, or for and, both parts have to be true for it to be true. Okay. Something, again, you learned back in middle school. Anyway, we can use these to make complex kinds of decisions. Here we've got students applying to some mythical college. We're going to try to figure out who to accept, who not to accept. A lot of HR departments do something similar to this, trying to figure out which candidates to bring in for interviews or to hire and stuff like that. There's lots of different reasons why you'd want to use this. Anyway, over here, on the left, some basic information. We gave them some sort of test to assess their verbal skills, their math skills, their grade from high school, their class rank from high school, and then we had them write an essay, and we graded it A, B, C, D, E, with A being good, and so on. All right. So then we came up with a set of cut points that we've been using in the past. If your verbal score is greater than 625, same for your math, or if your class rank is greater than 80, your grade is higher than an 85, your GPA from high school, and then so on. All right. Now I set this up this way because we're going to use this to make all sorts of decisions, and we want to make it flexible so we can come back and change things to do that. So over here, that's just a Boolean expression. Is cell D6 greater than D4? And it looks at the values in those two cells, makes a comparison. If it's indeed bigger, then it puts a true there. If it's not bigger, then it puts a false there. Okay. So you can do that sort of stuff. Okay. And so I just did that for that rule, and then I did for that rule, and the same here, and same here. All right. So basically, we're just saying, did they pass that criteria? Okay. So we got that sort of stuff. All right. Now, we're a highly selective college, and we said if you meet or exceed 4 out of those 5 criteria, we'll accept you. Okay. So it could be the first 4, the second, the last 4, first 2, last 2, whatever, some combination, right? Any combination will work. So to do that, we have to start looking at various combinations. An and statement is said to be true if all parts are true. If any part of it is false, then it's a false statement. So you can have, I'm male and I'm over 21, I live in New York, I work at SUNY Geneseo. There's 4 different assertions there. If all 4 of those are true, then that's a true statement. Any part of that's false, it's said to be a false statement, so on. So you can have as many of these clauses as you want. So, okay, so I did that one. So I basically looked at these first 4. Are they all true? Okay. And then I did the same over here for each. So I figured out all the different combinations of 4 that I could get from that. All right. And so if this is true, then we're going to accept you. If this is true, or if this is true, or if this is true, or if this is true. So combination 1, or combination 2, or combination 3, or combination 4, or combination 5. Or, right? With or statements. An or statement is said to be true if any one part of it is true. Okay. I'm female. I'm under 21, I live in New York. That's said to be a true statement because I live in New York. The other parts are patently false, but it's still a true statement because of the way Boolean logic works. Does that make sense? All right, so knowing that, then over here, I can just do ORs. If there's, in this row here, if there, any one of these is true, if any one of these is true, then it's a true statement. Then we want to let them in. So I just used the OR function there, and I did that. And then I just copied that formula down, and there's that sort of stuff. Okay. Now, one thing I'm going to do to help me here is I'm going to highlight this stuff. Again, conditional formatting is of use here. Equals 2. And I'm just going to say true. And we'll use green text. Okay. It just makes it a little bit easier to see what's going on. And I'll do the same over here. Okay. It just helps when we look at this thing. All right. So a basic Boolean statement returns a true or false. Then we used and. And says that all parts have to be true for it to be a true statement. And then lastly over here, or. The or says that any one of these Boolean assertions inside the parentheses, if any one of them is true, it's a true statement. Okay. And then we can do this. Now, this is great, but if you look down here at the bottom, we're only accepting 24 students. Okay. And that may be not enough, right? We need to bring in a certain number of students to, keep up our reputation, to keep, the class size right, to keep enough revenue coming in, all those sorts of things. So if we wanted to say, well, let's relax that a little bit and go to 3 out of 5. Then you got problems because my little note up there says to do 3 out of 5, you have to create 10 of those columns. All right. So there's a lot of work involved there. So the next thing I want to show you is a shortcut when you're doing stuff like this. Well, there's 2 ways to do this. This is the shortcut. If you add up trues and falses, it treats trues as 1s and falses as 0s. So I use this computer science trick here. If you're uncomfortable with that, you can just do a COUNTIF there and count up the number of trues. Okay. Either way it will work nicely there. And then over here, you just simply say if the count of trues is greater than or equal to 4, then it's a true statement. So then all I have to do here, if I want to relax my criteria a little bit, is to go, I just type 3 in up here now, and I'm done. Okay. So when you're playing around with this sort of stuff, you get situations like this where you got a lot of different criteria and stuff. Just counting up the trues or the falses, depending on how your problem's structured, is a quick way to do that instead of trying to do all these different combinations. Which is also why I set this thing up this way, because if I find I'm too restrictive or not restrictive enough, I can just simply come back here and say, well, 625, that's pretty high. Let's make that like 550. And then all I have to do is just change the number here, and it automatically updates everything in there. And so I don't have to go back in through my formulas and stuff like that. So this is a well-designed spreadsheet, and that I can play with and do all sorts of analysis. And why is that? What happened to my formatting? Oh. Anyway, so question about ands and ors? Or counting them up, or doing any of that good stuff here? Okay. So on the next page, you get to plan like you're a health insurance company, I guess, and you're going to assess people for various health risk, and you're going to put over here true falses. These are just hard coded in there, so you're going to want to put formulas in there instead. And up here, these little comments. If you just hover over that, it tells you what the criteria is for that risk factor right there. Okay, so go ahead and write a rule to test each one of those things.